A p-value is a score from a statistical test that helps you decide whether the results of your study happened just by chance. The level of statistical significance is often expressed as a p-value between 0 and 1. If the p-value is small, it suggests the results are not likely due to random chance and could be meaningful. If the p-value is big, it suggests your results could be a coincidence and are not statistically significant. A common threshold for statistical significance is a p-value less than 0.05, which suggests there is less than a 5% chance the observed data would occur if the null hypothesis were true. A p-value of 0.05 implies that if we replicated our experiment or survey 100 times, maintaining identical conditions, we could anticipate achieving similar or more extreme results by chance around 5 times. In a one-tailed test, the entire significance level is allocated to one tail of the standard normal distribution curve. For example, if you use a significance level of 0.05, you would reject the null hypothesis if your data point falls in the 5% tail on either the right or left side. In a standard normal distribution, a p-value of 0.05 corresponds to a z-score of 1.645. If we're talking about a two-tailed test, a p-value of 0.05 is split across both tails, so it corresponds to approximately plus or minus 1.96 standard deviations from the mean. This means that roughly 2.5% of the data lie beyond this point on either end of the distribution curve, totaling 5%. Any data point landing in these extreme regions would be considered statistically significant at the 0.05 level, leading you to reject the null hypothesis.